Hello everyone, and welcome back to another GIS Mathematics lecture video. And in this lecture video, I want to continue our discussion talking about the determinant. And I want to sort of reiterate this idea that all we know how to do right now is a 2x2 matrix. And what we did in the previous video is we went through 3 examples using the equation that I provided in the video before that, to be able to solve this determinant for a 2x2 case, right? As long as we could break this down into an A, B, C, D case, right? 2 rows, 2 columns, we could use this little equation here to quickly figure out the determinant, right? It was almost trivial in a sense. But if I were to give you a 3x3 matrix, say something like this, that's supposed to be a 4, not that it really matters, right? And I said, here's a 3x3, right? Give me the determinant. Right? You'd probably cry because we only know how to handle something that we have A, B, C, and D, right? We have 9 letters here. So how would we approach this? And in knowing how to approach this, I can finally go back and address the question of why this equation works the way that it does. But in order to address this larger case here, we actually have to introduce some new terminology and a couple of new notations. And so what I want to do here is I want to delete this so we're not confused. I want to scroll down and give us a little bit of room here. And I want to talk about 2 things. I want to talk about this idea of the matrix minor and the cofactor. I want to talk about matrix minor first, and then I want to talk about cofactor second. And I want to introduce some notation. So basically, what the matrix minor is you can think of the matrix minor as being a subset of the matrix created by removing 1 row and 1 column. Right? So if you think back when we talked about augmenting matrices, we said that we could take 2 different matrices and sort of smash them together. Right? Matrix minor is kind of the opposite approach in a way. Right? Instead of adding more values to create a larger matrix, we're actually taking out values to create a smaller matrix. And in specific, right, we're removing 1 row and 1 column. Okay? So what I want to do is I want to sort of denote the fact that we have a matrix minor. If we have our matrix A, right, if we denote the matrix minor, right, we denote that using the subscript I and the subscript J. Right, so in this case, I is going to be the row we remove. Right, so again, a subset of a matrix created by removing 1 row and 1 column. Notation-wise, right, we denote, right, a matrix minor. Right, we denote this by saying A, so this is our matrix. If we have a subscript I and a subscript J, right, we're denoting that we're actually creating a matrix minor by removing row I. Actually, you know what? I'm going to use blue here. I don't want to use green. I want to use blue. And the column we remove. Right, so this is the notation. right? When we're talking about a matrix minor, right, we're removing one column and one row. We designate the row with an I, and we designate the column in the second position with the J. So let's take a look at an example of the matrix minor. I'm going to use a generic example with a 3x3 matrix. We have A, B, C, D, E, F, G, H, I. Maybe this wasn't the best example because I don't want you to get confused with this I versus this I. Right, but if we were to take, if this is A, right, let's see what the matrix minor of A, and I'm going to use red here, of 2, comma, 3. Right, so what would this be? Right, so if we look at this, we're saying go to A, right, reference A. That's what this is telling us to do. Then this is saying remove, right, the second row. So that means we would remove, right, the second row. So that's this row here, right? We would remove that. And then also, right, remove the third column. So that would be this column here, right? We're going to remove that. Right, so if we do that, what do we end up with? We end up with A and B. And we end up with G and H. Right? Let me undo a little bit here because I want to undo the dashed line so we don't make this too messy here. Right, but if we do that again, right, we end up with A, B, and G, and H. Right, because we removed the second column and we removed, or sorry, second row, and we removed the third column. So what was left was A and B and G and H. So that's one. Let's look at another example because I really want you to understand this idea of the matrix minor. Okay, let's do an A where we remove 1 and we remove 1. Right, so what is the matrix minor of A1, 1? Right, again, right, this one tells us that we're removing the first row, so we would remove this row here. This one is telling us to remove the first column, so we would remove this column. Right, again, right, the first number here is the row that we remove. The second number here is the column that we remove. So in this case, we're removing the first row and the first column, right? So first row, first column. I'm gonna undo the dashed lines here so we can use this for another example. Right, but if we remove, right, that first row and first column, what we're left with is this right here. So our matrix minor is E, F, H, I. Right, this right here is our matrix minor for A. Matrix minor 1, 1. Okay? I want to do one more example. Let's look at the matrix minor of 3. Nope, sorry, wrong color. I'm trying to stick with the color scheme here. Of 3, 1. So what I'd like you to do is maybe pause the video, see if you can think about what the matrix minor 3, 1 would look like, what letters we would be left with. Pause the video now, think about it for a second. Okay, so hopefully you came up with the answer. Again, we're removing the third row, which is GHI, and we're removing the first column, which is ADG. So what we would be left with is B, C, E, F. Okay? Hopefully that makes sense. Again, this is the matrix minor. Let's do one last example with actual numbers. I'm going to scroll down a little bit here. I'm going to define B as the matrix 3, 7, 8, 2, 4, 5, 1, 2, 3. All right, and let's take the matrix minor of B with I equal to 3 and J equal to 2. I'm going to write over these with red, 3 and 2. And let's go ahead and quickly talk about what we're going to end up with, right? So we're moving one row and one column, so we're going to end up with a 2 by 2 matrix, right? This is the exact same example that we talked about before. And we're going to be removing the third row, which is going to be this row here, so we're going to remove that. Right, we're removing the second column, which is going to be this, so we're going to remove that. And if we do that, we're left with a 3, an 8, a 2, and a 5. So again, right, matrix minor, 3, 2, removing the third row, second column, we're taking whatever is left and we're making a new matrix out of that. This is the concept of the matrix minor. So hopefully this makes sense. I know we went through a couple of examples. If you have any questions, please reach out. Thank you.